Greetings, dear friends. I received a Nikon D7100 DSLR camera for repair. It's defective and won't turn on. We took it somewhere for diagnostics, but without results. A couple of spare circuit boards were included. Their functionality is highly questionable, but they might be useful as spare parts. So, let's test the defect. I install the battery and try to turn on the camera. It doesn't turn on and nothing appears on the screen. I check the battery, it's charged. So, the problem is with the camera itself. We'll investigate. As you can see, it's seen a lot in its life. I'm guessing it's been disassembled many times already. Well, it's my turn. I unscrew the housing screws and disassemble the camera, piece by piece. Along the way, I visually inspect the integrity of the cables and other components. Mostly, everything is fine. The only obvious flaw is a melted connector on the flash capacitor cable. I don't recall ever encountering something like this before. Luckily, the wires and contacts remained intact. I also noticed traces of water damage on some fasteners, although the electronic boards didn't have any significant corrosion. Otherwise, I found no obvious defects. I started the diagnostics by checking the board that receives power from the battery. Let's call it the power board. There's a fuse on the positive contact of the battery connector, which, upon inspection, turned out to be open. That is, the blown fuse marked T. I replaced it with a new one. It's slightly larger, but also fits here without a problem. I just had to prepare a new mounting contact for it. There is no short circuit in the power supply. I can connect the battery and check the operation. The soldering of some of the wires seemed poor, so I decided to re-solder them. I connected all the wires and cables, installed the battery, and tested the camera. The camera still doesn't turn on. Although, to be honest, I thought the repair would be complete with the fuse. Well, let's look further. I measured the voltage at the battery connector contacts. It's about 1 volt, which is certainly low. There's a short somewhere in the power supply system. To further diagnose the problem, I need to power the device from a laboratory power source. To do this, I solder wires to the battery connector contacts. Then I connect the power supply from the laboratory power source. The voltage is 8 V. I limited the current to 2 amps. Using a thermal imager, I identified the component causing the short circuit. It turned out to be a small diode on the same board. I desoldered it and tested it outside the circuit. It was shorted, meaning it was broken, meaning it needed to be replaced. I found a diode in the exact same housing on the donor board, installing it in place of the faulty one. Of course, I observed the polarity. The working diode was in place. I connected the power supply. The short circuit was gone. The current was about 186 milliamperes. Good. I installed the top panel with the flash, connected the cables and wires, and tested the power. Excellent. There's a battery charge indicator. That's something. I can desolder the cables and connect the battery. The camera turned on with it. The screen displays the operating modes. When I press the shutter button, the shutter fires, and that's a success. It seems that the camera's problems have ended there, I'd like to say, but no. During testing, I discovered a faulty flash. When the flash is open, no photos are taken, and there's no light pulse. It seems as if the high-voltage storage capacitor isn't charging. However, the flash circuit board, which charges the capacitor, is in perfect condition. There are no defects on it. The flash drive mechanism is also in good condition. During diagnostics of this problem, I discovered a damaged cable extending from the flash unit. I repaired it, but it didn't help. During a detailed inspection of the components on the flash unit's cable, I noticed some missing components, but this is unlikely to be related to the malfunction. Here's the problem. I'm currently measuring the voltage on the storage capacitor using a multimeter. When I press the shutter button, the voltage rises slowly. This is abnormal. The voltage should rise quickly, up to 300 to 400 V. For some reason, the charging occurs in short pulses. This is visible on the oscilloscope. I also noticed that the black wire that runs from the power board to the flash board somehow loses ground when the storage capacitor charging system starts. I figured this out, again using an oscilloscope. This contact should be connected to ground, since it is indeed connected to ground on the flash board, but there is an open circuit on the power board. I didn't bother to determine exactly where on the board the open circuit occurred. I simply soldered the wire directly to the negative terminal of the battery connector. Overall, this solution shouldn't cause any problems with the camera's continued operation, as the fuse is installed on the positive side. After fixing the ground fault, the flash function was restored, and I found no other defects. I reassembled the camera, tested it as best I could without the lens, and that completed the repair. The camera has long since been returned to the subscriber, and I hope it won't develop any more defects anytime soon. Well, my dear friends, that's all for today. Thank you all for your attention, and I'll see you at other repairs. Until next time.